Hello everyone, welcome to this session on Numpy indexing and slicing. In previous session, we have already discussed the indexing and slicing concepts. In this session, we can discuss some more example for indexing and slicing in one-dimensional array. So before going to start indexing and slicing, first we have to remember the syntax for slicing. So this is the general syntax for performing slicing operation. Array of start colon, stop colon, step. So start, it represents starting index. This could be included. Stop, it represents ending index. This is excluded. Then step, it represents number of positions to move. Then positive step, which means in step value, if there is a positive value, then the direction should be left to right. Then negative step, if the step value become negative, then the direction should be right to left, that is it travels in reverse manner. Okay. So in this slide we will learn the basic slicing operation in a one-dimensional NumPy array. So first consider the array a equal to np dot array of 10, 20, 30, 40, 50. So this array contains 5 elements with indices ranging from 0 to 4. So index position starts from 0. So 0, this is index position 1, this is index position 2, this is index position 3, this is index position 4. So ranging from index position 0 to 4. Let us understand the slicing expression. So the first expression a of colon. So this expression selects all elements of the array since there is no start, stop or step value are specified. NumPy returns the complete array. So the output is 10, 20, 30, 40, 50. The next expression a of 1 colon 4. So here slicing starts from index 1 and stop before index 4. Therefore, the element at indices 1, 2, 3 are selected. So the output is 20, 30, 40. Remember, the stop index value is always excluded. Next expression a of colon 3. When the start index is omitted, NumPy automatically starts from index 0. It selects element until index 3, but the index position 3 will not be included. So the output becomes 10, 20, 30, which are the first 3 elements. Then next slicing expression a of 2 colon. So here slicing begins from index 2 and continue until the end of the array because we are not mentioning any stop value. So the output is 30, 40, 50. Next expression a of colon 2. So this expression introduces a step value of 2 because there is no start and stop. So NumPy starts from beginning and select every second element. So the output is 10, 30, 50. Then next slicing expression a of 1 colon 2. So this slice starts from index 1 and again move 2 positions at a time. Therefore the selected elements are 20, 40. Then next expression a of colon 3. So here the step value is 3 starting from index 0 and NumPy selects every third element. So the output is 10, 40. Then next expression a of 1 colon 5 colon 2. So this expression starts at index 1, stop before index 5 and move with a step of 2. So here the selected elements are 20 and 40. The next expression a of 0 colon 5 colon 3. So here slice begins at 0th position and it jump 3 positions at a time. So the output is 10, 40. So these example demonstrate how changing the start, stop and step value allows us to retrieve different portions of an array efficiently. And next slide. So in this slide we will focus on negative indexing and reverse slicing. Negative indexing allows to access elements starting from the end of the array. So if it is a -1, it represents the last element of the array. Okay, so in this first expression a of -1, so the index -1, it always represents the last element, therefore the output is 50. Then next expression a of -2, similarly -2, it represents the second last element. So the output is 40. Then the next expression a of -3 colon. So this expression starts from third last element and continue until the end. So the output is 30, 40, 50. Then next expression a of colon -2. So here NumPy starts from beginning and stop before the second last element. So the output is 10, 20, 30. The next expression a of minus 4 colon minus 1. So this slice uses only negative indices. It starts from minus 4, stop before minus 1. So it will be selecting 20, 30, 40. Then next expression a of colon colon minus 1. So this is one of the most commonly used slicing expression. So the step value minus 1, which means numpy traverses the array in reverse order. So the output is entirely reverse order 50, 40, 30, 20, 10. The next expression a of colon colon minus 2. So here numpy again traverses the array in a reverse order, but it selects every second element. So the output is 50, 30, 10. The next expression a of 4 colon 1 colon minus 1. So here the slice starts from index 4 and move backward until just after index 1. So the output is 50, 40, 30. So these examples show how negative indexing and reverse slicing make it easy to access elements from the end of the array. And this final slide, we will look at a few special slicing cases. These examples help us understand how NumPy behave when the slicing limits are unusual. So in this first expression, a of 3 colon 0 colon minus 1. So here slicing starts from index 3 and move backward until just after index 0. So the output is 40, 30, 20. The next expression a of 2 colon 2. So here the stop and start indices are same. So the start and stop indices are same. So since there are no elements between them, so NumPy return an empty array. The next expression a of 5 colon. The starting index is beyond the last element of the array. So instead of producing error, so NumPy it return an empty array. The next expression a of colon 10. In this case, the stop index is larger than the array size. So NumPy what it will do, it safely return all available elements. The next expression a of colon colon. So this is default slicing expression. It return every element of the array. So the output is 10, 20, 30, 40, 50. The next expression a of 1 colon. So this slice starts from index 1 and continue until the end. So the output is 20, 30, 40, 50. The next expression a of colon minus 1. So here NumPy selects every second element except the last one. So the output is 10, 20, 30, 40. The next expression a of minus 1 colon colon minus 1. So this expression starts from last element and move backward one position at a time. So the output is 50, 40, 30, 20, 10. Although it produces the same result as a colon colon minus 1, it explicitly starts from the last element before reversing. So NumPy slicing is flexible technique for accessing specific portion of an array. By adjusting the stop and step value, we can select continuous elements and we can skip elements and we can use negative indices or we can reverse the entire array. Mastering slicing is essential because it is widely used in data analysis, machine learning and scientific computing. I hope you can understand better about slicing and indexing for one-dimensional array. Thank you for watching.